So do the prime factorization for each one. So break up 32, factor 32, and factor 40, the top and bottom. So you have to know your times tables. What times what equals 32? Probably 8 and 4 is what comes to mind. And then 8 is 2 times 4. 4 is 2 times 2. How do you know when to stop? Yeah, when one of the factors is 1. So the only thing left with 2 is 2 and 1. So that's how you stop. 4, you can keep going. 2 and 2. You have to stop because those factors just 2 and 1. Okay. So these are all prime numbers. So that's the prime factorization for 32. So that's going to be 2 times 2 times 2 times 2 times 2. 40 will be very similar. What does 40 factor to? What are some factors of 40? Yeah, 4 and 10. 4, once again, is 2 and 2. 10 is 2 and 5. So here we go. 2 times 2 times 2 times 5. So now we can see 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. Those all cancel out. And whatever's left over is your answer. I'm left over with a 2 times 2, 4, and 5. Now, you see how we canceled out 2 times 2 times 2? What's 2 times 2 times 2? 8. That means another way of doing this would be to divide top and bottom by 8. But the problem is we don't know that just by looking at it. That's why this method works all the time. But if you could recognize at the beginning that the top and bottom divided by 8, that's what we just did. We canceled out 3 2's, which when you multiply them equals 8. So it's not like this is a different way and it's just magically gets the same answer. It's the same idea. All right, let's go down to, let's see here, maybe 4? Okay. Most of us can't look at 4 and say, well, I know the biggest number that goes into 72 and 180. Right? And this is where some of you are getting tripped up on the Khan Academy, because as soon as you got big numbers, you're like, well, I have no clue. When it was 2 over 4, you knew what to do, but this, not so much. But we have to know how to do these numbers as well. So again, foolproof method. Yes, it takes time, but then you always get 100%. So what multiplies to 72? And what multiplies to 180? 9 and what? 9 and 8, good. So 9 is 3 times 3. 8 is 4 times 2. But 4 is 2 times 2. Here's my prime factors. Okay. Factors of 180. So it ends in a 0, right? So what's a factor if it ends in a 0? Anything that ends in a 0, what goes into it evenly for sure? 10. 10 times what? 18. I know some of you looked at 180 like, I don't know. It's not on the multiplication chart, so I don't know it. But really, you do if you think about all your divisibility rules. So we got 10 is going to be 2 and 5. 18 will be 3 and 6, or 2 and 9. Either way, you'll get the same thing. Okay, there's all of those, 180. I tried to write them in order, so 2 times 2 times 3 times 3 times 5. There's 2 2's and 2 3's and a 5. 2 2's, 2 3's, and a 5. Okay. And now you can cancel. Remember, cancel means equals 1. 2 divided by 2 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. So I'm left over with 2 on top, 5 on the bottom. So what does that mean? What's the biggest number that goes into 72 and 180? What canceled out? 2 times 2, 3 times 3, 2 times 2 is 4, 3 times 3 is 9, 4 times 9 is 36. 36 was the biggest number that goes into 72 and 180. But you're probably not going to recognize it by looking at it. That's why we need this. If we knew our times tables up to 36, we would have done this. We would have said, oh, that's 36 times 2, and 180, that's 36 times 5, and we would have done that. That's the same thing we just did, but we had 36 broken up into prime numbers, 2 times 2 and 3 times 3. After enough practice, you do actually start catching on to some patterns, and you don't have to do this as much. But you have to start here to learn the patterns first. Question?
Will there ever be a chance where like there's just add another like a odd number where you can't like simplify it?
Well, like 8 over 9. If you try doing 8 over 9, right, you get 2 times 2 times 2, and 9 would be 3 times 3. So yeah, that would not simplify.
Well, what I mean is like when you when you get that problem like that,
Mm-hmm.
but when the top number or the bottom number just you can't simplify it at all.
They're both prime already?
Yeah.
Oh, I see. If you get like 17 over like 31.
Yeah.
And then, yeah, 17, that's just 17 and 1, and 31 is just 31 and 1.
Does that ever happen?
Right? Well, here's an example. So it can happen, but not on here. All these I've given you do reduce. But yeah, there are some, not every fraction reduces, is the question you're asking. Yeah, some of these already reduce, and some of them are prime, and they won't reduce. If they don't have any common factors, they can't reduce. That's a good question. Lastly, I think it was number... Oh, like 7. 12 and 24. I'm going to do 6 and 2. 2 and 3. 24, I'm going to do 2 and 12. And 2 and 6. And 2 and 3. So I know most of you probably saw, I'll do 6 and 4. That's fine. You'll get the same answer. Over here, you might have done 3 and 4. That's fine. You get the same answer. That's the thing about primes. It always comes out to the same prime numbers. So what happens if, on the top, everything cancels out? Okay, so 2 over 2, 2 over 2, 3 over 3, what's that answer? There's a 2 left over on the bottom. What goes on top? Or we just leave it blank? 1. Why a 1 though? Because what? Yeah, because 2 divided by 2 equals 1. 2 divided by 2 equals 1. 3 divided by 3 equals 1. That's why we have a 1. So canceling out doesn't mean disappears. It equals 1. It's just that often in algebra, we had like 2x over 2. We usually don't say that equals 1x. We're allowed to drop it and be x, but technically it's a 1. We just don't normally write in algebra But when it's not algebra, it's just arithmetic, there's no variables, you definitely have to have the 1. So it equals 1. Okay, so again, your priority here is accuracy. You want to be 100% correct. If you use this method, you will be 100% correct. You act as if you get $1 million for getting everything right, and you owe $1 million if you miss one thing. And then you spend that much attention to detail, and then you will get it right every time. Just don't let the end of the period coming mean let's speed up and get sloppy. Let's not let somebody else talking to you slow you down and get in your way. You have to be concerned about doing things right, not by just getting done and saying, look, I'm finished because I wrote something down. So Khan Academy is going to tell me who's doing what. Again, if you know how to do all this and this is super easy for you and you haven't gotten it done on Khan Academy, just use the back of this paper for your scratch paper. You probably just need to write it out and show your work, and you'll get 10 in a row correct, no problem. Okay. But yeah, anything from elementary school, I'm assuming that you guys should be able to get it right 100% of the time. There's nothing you should be missing. Okay? So expect that from yourself. Raise that expectation for yourself that if you learned it in elementary, you should get it right every time.